Hi, everybody. Yes, I'm George. Thank you, Mary, for the introduction. Thanks, Lead Dev, for having me. That's all I needed for an introduction, so I'll just get started. I've been through a number of migrations, and I'd like to tell you about some of the things I've noticed and how it doesn't always go as planned. So, over my time at ThoughtWorks, at one point, I worked with an airline. Let's call them Boxstyle Airlines. They were founded during the heyday of air travel. They were founded by aviation superstars Orville and Wilbur Redenbacher. They are notably the fourth US domestic East Coast regional carrier with a computerized reservation system, so they're kind of a big deal. And 3 years ago, they had a monolith. So this monolith had been around since they picked up their reservation system about 15, 20 years ago. It integrated with third-party services, had an old relational database where there was at least one other application integrating with it. We weren't sure, maybe more. And then it had a classic sort of big ball of mud, tangled mess for the monolith, where it had a front end where we weren't really sure. Maybe there's business logic in the front end, presentation logic in the back end, like a classic anti-patterns. So one day, anytime we asked developers to develop new features in it, we got this reaction. So one day, a very senior architect came along and said, let's do microservices. And we were like, why should we do microservices? And this architect said, because we'll get scalability, faster feature development, we'll have developer autonomy, we'll get to work with new technologies finally, we'll have actually tested code, encapsulation, and maybe we'll do CD. And for a while, we thought it would look like this. But the reality was that we ended up here, where we had just we had significantly increased our complexity, our architectural complexity. We had added abstraction layers in front of our third-party service. We had failed to do anything about our database integration, and in an effort to give our microservices their own data store, we had to run ETLs daily. And really, at the center of it all, there was still a monolith that we had neglected. So these new layers of abstractions and the new complexity in data replication meant that finding a bug often felt like this. And our deployment meetings often felt like this, the General Assembly at the UN, where we had QA representation. They were tired of finding defects in production. We had the operations, their representation. They were tired of maintaining an increasingly complex system. And because we had highly coupled services that had to be deployed, or that could not be deployed independently and had to be deployed all at once, we had really ended up with a distributed monolith. We had lost sight of the many benefits that microservices had to offer because we had fallen trapped to a number of traps. And I'll talk about these in detail, but I'll go through them right now. The traps are underestimating the cost of a microservice, overcentralization, and this is twofold, technical and organizational, and then also neglecting the monolith, which is my favorite. I'll begin with underestimating the cost of a microservice. Developing and maintaining a microservice is fundamentally different from the way that you're going to be doing it or that you had been doing it with your monolith. And this will make starting down that path quite costly, and especially if you underestimate these costs up front. So I'll run through a couple buckets of these costs. Operational costs. So as I showed earlier, we had abstracted some of our interactions with a third-party vendor by building a RESTful service in front of it. And this third-party service was, for the most part, reliable until one day it wasn't. And on that day, the airline, the booking flow had mysteriously broken. Customers were unable to book flights. And it took several hours of debugging to realize that several service calls away, an HTTP call had been timing out. And debugging a distributed system can be really difficult if your logging is not up to snuff, and especially if you don't have log aggregation, which never go into microservices without log aggregation. A failure in one microservice might not show up until several service calls later, the needle in the haystack. Another cost that's overlooked is scaling. It's supposed to be a benefit of microservices, but it will require an understanding and dealing with a whole new set of infrastructure than you're used to coming from the monolith. And not to say that there aren't a lot of new tools around this, and a lot of cloud platforms are abstracting the way we think about this concept. And the next cost is build and deploy pipelines. See, these are also going to be very different from the way you do it with your monolith. And I highly recommend that your teams maintain their own build and deploy pipelines. It's going to help you build more maintainable pipelines. It's going to help your teams understand the whole process and stop from proliferating a lot of complexity. But I'll talk about this later when I get to overcentralization. The next bucket I'd like to talk about are integration costs. So what used to be, so these are integration costs of your microservice with other services and with the monolith. What used to be simple function calls protected by the compiler is now JSON flying over the wire over HTTP. And when we make changes to our APIs, we need to make sure that we haven't broken our contracts with our clients. And if we rely on calls to other services, we need to make sure that our clients haven't broken their contracts with us. Which brings me to error handling. What if our clients did break their contracts? Or what if they're down? Now we need to think about retries, circuit breakers, the transactionality of this operation. If it takes 3 calls to other services to do a whole transaction, what if the 3rd call fails? Do we have to roll everything back? These aren't always concerns in your monolith, and we didn't realize these on our way in implementing these up front. And then also, if we're developing an externally facing service, we might want to obfuscate the inner workings of our microservice. So, for instance, not returning a stack trace in a public API. Thank you. So another group of costs I'd like to talk about are developers' costs. If I'm developing a microservice that keeps track of, say, a customer service, right, all the users of my application, I might need to integrate with a payment service where a secure place to store the customer's payment methods, or maybe an address validation service so that I can validate that the address the user has entered is actually a real address. So as I'm developing my microservice, I'm going to need to probably be running some of these services locally. This is going to be a lot of overhead for the developers. Additionally, each service might need its own data store. And also, I need to worry about routing all the calls appropriately between services to either services I'm running locally or maybe that are running in a shared test environment. There's also, for a developer, a lot of overhead with communicating with other teams. Like, what if I need some additional information exposed from an API I'm consuming? Or what if that API I'm consuming just isn't even well documented? Some of these costs can be mitigated by automation. A concept that I'm a big fan of, I've heard referred to as a Dev Workstation. It's basically like a shell script or a Docker Compose file. It could be anything that just allows me to simply spin up all the services and infrastructure I need to develop a particular feature set. It could take care of something like stubbing out certain service calls, spinning up a test database with a lean data set so I can develop against some realistic scenarios. And it could take care of wiring up the network config so I can route my calls appropriately to services local or otherwise. Another pattern that I recommend to mitigate some of these integration costs and communication costs are contract tests. You can write your own contract tests, which execute bits of your code that will execute calls to other services, ensure that you can serialize and deserialize the payloads properly. Or another pattern are consumer-driven contract tests, where the clients of your API will actually give you a spec or some sort of schema to run against your own API responses to make sure that you haven't broken your client's expectations. I encourage you to look into both of these patterns, and they can be run in your CI environment on every build. So I talked about mitigating developers' costs and the cost of integration, but what about operational costs? One thing the airlines did was that they decided to undertake the whole migration into microservices all at once. And for an organization that wasn't quite ready or sure how to implement microservices, this was a huge cost. Every cost that they incurred was compounded by the scale of the decision. It was very much so a macro decision, and it should have been a micro decision. So I actually studied economics in undergraduate, which this is not really a frightening equation. Really, all it's saying is you should be driving some benefit from every microservice that you define and deploy. And I talked a little bit how we can reduce the costs, like the right side of this, so that you can, derive some benefit. But I think it'd be also useful to talk about how we can maximize the benefits of every microservice. And if we're thinking about where we can start to actually derive the most benefit, let's think about what the actual benefits of microservices are. Faster feature development. If there's a part of your business that's looking to grow more quickly than others, maybe this is a good place to start with microservices. Maybe a good place to start with microservices is somewhere where you want to isolate this part of your functionality, for instance, a payment gateway or an auth system, where it'd be good to draw strict network boundaries around that part of your application. Or maybe you want to pick a place where you're doing some video processing now and you want to write a service in Golang or some sort of like vector optimized language. This would be a good place to write a new service. Or as part of your application or your business that scales. For the airline, flight status during a storm was something that they had to scale independently of a lot of other parts of their application. Or maybe there's just a part of your application that is full of tech debt and nobody likes working in it, and it's time to pull it out into a microservice simply because nobody wants to work on the legacy code. So my recommendation, start in one place as a proof of concept. As you get further into the process, reevaluate this. If it doesn't hold true, you can think about investing in some automation, some additional tooling, some upskilling, or maybe just back out and say this isn't for us. The next trap I'd like to talk about is overcentralization. And this, as I mentioned, is technical and organizational. I'll start with technical, which is probably the less obvious of the two, because I'm going to talk about too much shared code. Naturally, this happens in an effort to create efficiency, and what developer doesn't love being efficient? But every instance of shared code between microservices is a potential point of coupling. So the airlines that I worked with, they built a communication library where it was communication over a bus, and every microservice that wanted to communicate with each other had to import this library and communicate in this way. And it tied them to a very particular communication protocol and actually caused some really complex release dependencies, where I remember a service that we were working on wanted to upgrade one of our dependencies, say version 3.2 to 3.3, but the communication library still relied on 3.2. A breaking API change meant that we had to upgrade the version in the communication library, which meant that we had to upgrade the version in all the services and all the libraries that they imported, and we got back into that distributed monolith pattern where we had to deploy all the services all at once. Additionally, these sorts of practices can tie you to a particular tech stack where you lose the autonomy that microservices are supposed to provide. So how do we avoid this? Simple. Just don't do it. Well, I'm kidding. That's not always possible. But you could do things like follow the principles of library design to keep your code should be narrow in scope and really only be used to reduce code rewrites. And I'll follow that by saying rely on a consensus of standards over a shared implementation. For instance, HTTP status codes are really awesome for communicating responses and what they mean. And that's definitely a shared consensus. Like you can, yeah. The other thing I'd like to say is make sure you don't implement business code in any sort of business logic in any sort of shared library. You're going to end up where if you have to make changes to the business logic in that library, you're going to end up in the same sort of distributed monolith case where all of the services that depend on that logic have to be deployed at once, that your logic does not get out of date. So moving on to organizational overcentralization, otherwise known as silos. So as we were working on the customer service, where they kept track of all the customers' interactions with the website, we were finishing it up and ready to go to prod, and we were really excited about getting our service into that, that golden place of prod. But there was something holding us back. QA said, hold up, guys. You can't just deploy whenever you want. You have to get on our monthly release schedule. And it felt like being stuck in traffic. They tightly controlled what functionality went into every release, and they defined when the releases would happen. And we were kind of bummed because we weren't going to get the quick feedback that microservices promised. And the business was kind of bummed because they weren't going to get the features deployed as quickly as they wanted. And we were worried that if something went wrong during that one monthly deploy, we might have to roll back and then wait for the next month to deploy the fix. But why was QA doing this to us? Well, from their perspective, this is what they saw. They saw themselves as the final wall of defense against the ever-growing backlog of production defects. They understood that with microservices came a huge increase in the complexity of the architecture, and there was so many more points of failure and things that could go wrong. And they'd been burned a couple times before by other teams before us. So they put us on the deployment schedule, which was to give them enough time to QA the whole feature set that was going to go out that month. And really the lesson here is that with microservices has to come a change in your company's culture and organization. QA and ops need to be as intimately familiar as the developers are who are working on this microservice. The QA and the ops need to know what to test, how to maintain it, what sort of errors to expect. And your developers need to wear more hats too, because as they test and maintain their own applications, they're going to feel the pains and challenges of logging and monitoring a distributed application. Consequently, these will be concerns as they develop, and they'll develop more maintainable, more debuggable sorts of applications. And it's going to be a learning experience for everybody. So finally, the last trap, and my favorite trap, neglecting the monolith. So 3 years ago, the airline set out on their path towards microservices, and it was long, and it was painful, and kind of fun. But the truth that we came to realize was that we realized the falsehood of this statement. I'm sure many of you have heard this before. And this sort of mistaken attitude can lead developers to liberally add a lot of tech debt to the monolith and write really crappy code. And when we think our code is throwaway, we write really bad code. And it's okay to get excited about the new tech stacks, but you got to show your monolith some love. Because ultimately, and most likely, the core of your business functionality is still within that monolith. You can show your monolith some love by writing tests. That's a really great way to start. And no, your monolith is not impossible to test. Adding test coverage can be a daunting task, especially for a monolith that is not well tested. But a good place to start would be to cover your core business functionality. So let's write a smoke test that every time we deploy our monolith, we know that we haven't broken the booking flow, so that people can still buy flights. Otherwise, all is lost. And then the next place to start testing might be where you plan to make changes, where you plan to pull functionality out of the monolith and into the microservices, so that you can do this more confidently. And in testing your monolith, I highly recommend that you engage your business to understand what the desired functionality is, and to end up duplicating faulty logic that was never properly implemented in the first place. And then another way to show some love is to automate your monolith. Are your deploys manual? Automate it. Can you run it locally? Let's work on that. This will make your life easier in the long run. So here's another mistaken belief, is that microservices are going to solve all of our problems. This is false. You can always be improving your architecture. And in fact, there are a couple ways that you can improve your architecture and improve your monolith before you even start thinking about pulling this out of your microservices. For instance, improving the modularity of your code. Service definition often starts within the monolith. High coupling within your monolith between domain boundaries is going to make it really difficult to pull out this functionality into a microservice. So strive for loose coupling, high cohesion. It's sort of outside the scope of this talk, but look into the principles of domain-driven design. Also, make sure you're thinking about mitigating database integration, because as you pull data out of your monolith to your microservice, it's actually going to be really difficult if your microservice can't own its own data. It's going to be impossible for the microservice to own its own logic if it can't own its own data. So make sure that you're always using the strangler pattern. What is the strangler pattern? It's sort of the pattern where in the monolith you'll be gradually replacing code with calls to external services. So in the ideal scenario, the monolith slowly has business logic replaced with service calls to your microservice, deleting the logic and the code in the monolith until it's basically just a small wrapper service or orchestrator written in a legacy tech stack. So, assuming you've shown your monolith some love, eliminated your database integration, no easy task, I'm telling you, drawn your domain boundaries correctly, properly tested your monolith, you're ready to pull your logic out into a microservice. This is really daunting, but what I'm trying to suggest is don't rush into it. Start with a proof of concept, make sure your organization's ready, and here are a couple, and keep in mind the traps. I talked about these, hopefully it made sense. So here's some parting words for you. Keep in mind the marginal utility of a microservice. Make sure you're always deriving benefits, and if not, go back and reevaluate. Make room for autonomy. Don't put so much process in place that you strangle autonomy. Sorry. And make sure that your teams own the whole process from start to finish. Break down the silos in your organization. It'll help you keep the complexity from spiraling out of control. And lastly, it doesn't take moving to microservices to make changes or incremental improvements to your architecture. Your architecture can and should always be getting better, sort of on that Boy Scout principle, leave it better than you found it. So ride those microservices off into the sunset. Thank you.